Hi everyone, this lesson is for Algebra 2 Honors students to help you prepare for your next quiz, which will be over chapters 7 and 8. This is a last minute Lucy, although this is not Lucy, this is Shanghai, New Marvel. Anyway, this particular video tutorial has extras in it, so that are in addition to the practice quiz, but most of the questions will be off the practice quiz. So let's get started. The first thing we're going to talk about is just a little bit of review of radicals, which you do need to know for the quiz. Additionally, you've got 4 root 3 over 5 root 5. And what you need to remember to do is to, when you're dividing, that numbers divide with numbers and roots divide with roots. So, of course, this isn't going to cancel. These aren't going to be reduced. So our next option is to remove the root or radical from the denominator by multiplying by itself. So we're going to multiply by root 5 over root 5. Just this, we're not multiplying by 5. You can have a number on the denominator. And so what we get on the numerator is 4 root 15 over 5, this 5, times this, which is root 25, which is 5. So we have 5 times 5, and that's going to be 25. And so we would leave our answer like that. Now remember, 25, even though 5 goes into 15 and 25, one's a root and one isn't, and you're not going to be able to reduce that. You're done. For this next problem, you all have a root on the denominator, but this root also contains a variable. So you do need to, when you're multiplying by root 3, you're also going to be multiplying by root 3a. In order to get rid of that. So in doing that, we're going to get 5 root 3a over, and then of course, just to show you, this is going to be 9, 3 times 3 is 9a squared, which is the same thing as the square root of 9 times the square root of a squared. So that's 3a. So we're going to have 3a on the denominator, and we're done. For this problem here on the left, again, it's a square root. So you're looking for values that you can take 2 of out. So the 6 is going to stay there. But root 75 actually is going to be 25 times 3. M is going to stay. P squared, that's going to come out because that's a perfect square. And then we're going to have Q to the third power. I'm going to make that Q squared times Q. And so when I'm pulling things out, of course, I can split them up like I did here, but what I also can do is just cross them out as I pull them out of the root. So it's going to be 6 times. This 25 is going to be a 5. 3 stays, M stays. P squared is going to be times P. Q squared will be times Q. And then you've got this Q left. And so this is going to be 30 PQ times the square root of 3 times M times Q, and that's all going to be inside like that. And then you're done. You just box that up. You didn't solve anything. It's just a expression. For this problem here, remember, roots can cancel with roots. And so values that have the same value on the top and the bottom can cancel. It's as if this was, let's say, root 10 divided by root 10. Those are going to cancel. So the y cubes are going to cancel. One of these x's will cancel with one of those. So this x is going to be gone. That x, I have 1 left. So I'm going to cross out that 2. So I'm going to rewrite this. And what I have is the square root of 3x over 4 root 5. So now what I need to do is I need to remove the root 5. And so I'm going to multiply by root 5 over root 5. And my next value is going to be the square root of 15x all over, and this is going to be 4 times what this is, and that's 5. So 4 times 5 is 20, and we can have a number on the denominator, and we're done. For these reviewing of radicals also on your quiz, we just need to remember that you can only add radicals that have the same value. So for example, root 3 plus 2 root 3 is going to be 3 root 3. So this is 1 plus 2. Numbers get added with numbers, and then these are like x's. They stay the same. You don't do anything with them unless you're actually multiplying, which we're not. So what we're going to do now is we're going to say, okay, so I want to take this and I want to try to reduce what I can. So I've got negative 2 times the square root of 45, which is 9 times root 5, minus 3 times that. I'm trying to think perfect squares, right? So like 4 times root 5. And then minus 2 root 6 doesn't have a root that's a perfect square within that. So for this one term here, so there's 3 terms here total. There's that one, and that one. So for this first one, you've got negative 2 times, this is 3. So that's going to be negative 6 root 5. This right here is a 2. 2 times negative 3 is going to be negative 6 root 5. And then this is minus 2 root 6. So like values can be combined. So that's going to be negative 12 root 5 minus 2 root 6. And you're done. The only other option that you could do, of course, is you could factor out a negative 2. And then you would have 6 root 5 plus root 6. And then that's completely optional that you do that. Of course, you want to make sure you look to see what values are available if there's a multiple choice option. For this problem here, we want to distribute this root with the, and remember, numbers get multiplied with numbers. So this number out front of the 2 and this number out front of the root 10, those are going to be multiplied. So I have negative 1 times 1, which is negative 1. And then root 2 times root 10 is going to be the square root of 20. And then root 2 times this value here, negative times negative is going to be positive. The 1 is going to multiply by the 4, so it's going to be 4, and then root 12. Now that we did that, we actually need to reduce it if possible. In that aspect, we are going to break this down into root 4 times root 5. And this I'm going to break down to root 4 times root 3. And so when it's all said and done, I'm going to have this negative sign, and then this will be 2. So negative 2 root 5, and this is plus, so plus root 4 is 2, so plus 2 root 3. And then this would be my answer. Yes, of course, I can take out even a negative 2 if I wanted to. If I did that, I would have negative 2 times the square root of 5 minus root 3. And then I would just leave it like that. For this last problem, we are going to FOIL. And again, just some practice with foiling. You want to make sure that you can multiply numbers with numbers, roots with roots, etc. So we're going to have root 3 times root 3. That's 3. Then we're going to go outer, first FOIL, first outer, inside last. So root 3 times the last bit, which is going to be negative 5 times the square root of 15x. And then this one times this one right here is root 3 times 5x, which is going to be plus root 15x. And then this times this will be negative 5, because that 5 right here is getting multiplied by that 1, positive 1. And then root 5x times root 5x is just 5x. So this will be times just 5x. And so now simplifying, which is adding like terms, is going to be 3. We have negative 5 plus 1, so that's minus 4 root 15x, and then minus 20x. And so you would just leave your answer like that. There's nothing you can do about that. Everything's different. You just leave it. So for these problems here, these following problems are problems from your practice quiz. Most of them are very similar to the ones that you see on your quiz. Of course, they're all different. So we're going to start with this one. Find the sum of the solutions to this equation. So you should know that this being quadratic, x times x squared, in order to split these up, let's say, and set each equal to that value, which is supposed to be 0, in order to do that, you would actually need to make this into a 0. So that means I need to set this equal to 0. So that means I do need to multiply everything out and then reevaluate. So we're going to get x squared plus x minus 2x, and then minus 2, and then move this 4 over, so minus 4. So we have x squared minus x minus 6 is equal to 0. I'm going to split that up and factor. So I get x minus 3, and I get x plus 2. I'm going to split this up, and I'm going to get x is equal to negative 2. I'm going to get x equals 3. So my solution set is going to contain both negative 2 and 3, and I'm done. For this problem here, your job is to solve for x, and I would then You have an option of moving this 8 over if you wanted to, but I'm just going to square both sides right here. And in doing that, on the left side, I get x minus 2. On the right side, I'm going to get x squared, and then negative 8x and negative 8x is negative 16x, and then plus 64. So again, it's quadratic. You need to set it equal to 0. You get x squared, and then you're going to subtract x from both sides. So you get minus 17x, and then we're going to add 2. So that's going to be plus 66. And again, I'm going to factor. You can always use the quadratic formula, or wait for it, use the quadratic formula on your calculator. Hey, what a great idea. Look in the slate. I think, let's see, back, couple chapters back, and then you'll see the program for that right on the slate. This is x minus, I'm going to go with 11 and minus 6, which is negative 17. Set equal to 0. I get x equal to 11, and I'm going to get x equals 6. So my solution set, which you do need to put your answer in a solution set, will be 6 and 11. Now, the only thing about this stuff is that with roots, it's kind of tricky because you feel like you're done and you're ready to move on, except for you may not be. And so when you are using a square root function like this, okay, so I'm going to erase this here for a second. It is possible that you're going to have something called extraneous solutions. And those are solutions. So extraneous solutions are answers to your equation that actually don't work when you plug them back in. Okay, so even though I've got 6 and 11, and usually I just wait to put the solution sets in, I usually don't put those in. So I'm going to like back up a little bit, because what should happen is that you check your answers. So let's try this first. So let's go, let's see, we've got 11 minus 2. So 11 minus 2 is 9. Square root of 9 is 3. Does that equal 11 minus 8? 11 minus 8 is negative 3. Is that right? And so if 11 minus 8 is, that's just 3. So if 3 is equal to 3, these are equal. So that does work. So far in my solution set, I do have 11 that does work. Now in this problem here for 6, I'm going to plug that in. I get the square root of 6 minus 2. Does that equal 6 minus 8? 6 minus 8 is negative 2. 6 minus 2 is 4. Square root of 4 is 2. Does 2 equal negative 2? That's a no. So 2 does not equal negative 2. So that means x does not equal 6 as a solution. So we would then put our answer, because you do have to show that that is a value that is extraneous. And so you would say, you could say 6, this value here is extraneous. So extraneous. So 11 is a solution, 6 is an answer, but not an actual solution. So for this problem here, in order to get rid of this fourth power, this is the same thing, or fourth root this is the same thing as having this to the 1/4 power. So see this here? That's to the 1 power equals 4. And so in order to get rid of the 1/4, we're going to multiply this to the 4th power. But remember, it is an equation, and whatever you do to one side, you do have to do to the other. So you have x plus 2, and these cancel, right? So x plus 2 equals 4 to the 4th power. So that's what, 16 times 16, which is 256. Subtract 2. So I get x equals 254. But again, I really just can't stress that you need to check your work. There's going to be multiple times when you are working these problems on your quiz, and you're going to get an answer, and you're going to feel very positive about it. But unfortunately, they're not going to all work, because we're going to know when you don't check your work. So plug this back in. So realistically, we have 254 plus 2 to the 1/4 power. Does that equal 4? So 254 plus 2 is 256 to the 1/4 power. 256 is, I believe we said 16 times 16. That's what I said. And 16 is actually 4 squared and 4 squared. So that's 4 to the 4th power. So that's going to be 4 to the 4th power to the 1/4 power. Well, 4 to the 4th power to the 1/4 power, those 4s are going to cancel, and you're going to get 4. And 4 does equal 4. So therefore, my answer, which is 254, or my solution, is the correct solution. So no extraneous solutions here. We just have one value as our answer. For this problem here, in order to get rid of this square root, I am going to square both sides. And again, it's completely fine if you choose to do x squared minus 16 to the 1/2 power equals 3, and then you are showing me in your work that you are squaring your answer. So I do expect to see this work. So anyway, so we get x squared minus 16 is equal to 9. I'm going to subtract 9 because, for these reasons, if you move this value over to the right, you're going to get x squared equals 25. And you got to make sure that you understand that you're going to have it squared, x squared, two solutions. And sometimes when you move this over and you get x squared equals 25, a lot of times you'll lose that one value. Where if you move this over to this side, you're going to get x squared minus 25 is equal to 0. And at this point, you might realize that, hey, this is a difference of two squares. And then when I do that, I get x plus 5 and then x minus 5. And then when I split that up, two answers again, x equals 5 and then x equals negative 5. And, you know, of course, if you can remember, you're going to get x equals plus or minus 5 for this kind of problem. Great. Remember also to plug your values in and check your work. And, you know, as you go through the key, you should see every single problem. It says check, check, check. All right, so we're going to check negative 5 first. So we're going to take, so let's see. What do I want to do? The square root of negative 5 times negative 5 is 25 minus 16. So 25 minus 16 is 9. Square root of 9 is 3. And for this value, that does equal 3, check. Now I'm going to plug in 5. 5 squared. Again, for this problem, I get 25. 25 minus 16 again is 9. 9 does equal 3. So for me, this problem is going to work with plus or minus 5 because both of my solutions actually work. For these problems here, and you are trying to solve for x, one thing that you do need to remember is that you have values on the denominator that may or may not work. When we call those values, we call those restrictions. So if this part right here, if you would set this equal, you go, hey, that cannot equal 0. So that means that x cannot equal 5 because 5 minus 5 would make that 0. So we know x can't be 5. If I set this one equal to 0, I also know x plus 5 equals 0, so x can also not equal negative 5. So when it's all said and done, after I finish this problem, I need to remember that I do have two restrictions in that there's two values that aren't going to work. Okay, so you need to remember that. Secondly, you have this common denominator here, which is x plus 5 and then x minus 5. There's multiple ways to solve these problems. I am going to choose to solve most of these problems by multiplying by a common denominator, and that's going to be x plus 5 and then x minus 5, because when I take this quantity here and I multiply it by each one of these terms, at least my denominator is going to cancel completely. So when I multiply this term by the first term, the x plus 5s cancel like that. And then I'm left with x minus 5 times 3x minus 1. When I multiply this term here, that quantity, by 32 over the same value, both of those values cancel. And so you're left with just plus 32. And then lastly, when I multiply this by this last term, the x minus 5s do cancel, and then I'm left with 3x plus 1, and then that's times x plus 5. So now all I have to do with this is I actually just need to multiply everything out and see what happens. So we've got x times 3x is going to be 3x squared. X times negative 1 is negative x. And then this will be minus 15x. And this will be plus 5. Then it'll be plus 32 equals. And now I'm going to FOIL this. And I'm going to get 3x squared. This times this is going to be plus 15x. Plus x, and then that's going to be plus 5. So anything that cancels, you should try to cancel off right off. 3x squared and 3x squared, those are gone. Let's see. Is that it? Let's see. It looks like a 5 might cancel. 5 and 5. So what's left? It looks like -1 and -15 is -16x. Need a little more room, I think. Plus 32 equals 15 plus 1 is 16x equals 16x. Okay, I'm going to move this 16x over to the right. And so on the left, I have 32 equals 32x. So it looks like x equals 1. But again, before I do anything, I'm going to check my solutions and make sure that I'm not going against any of my restrictions. My restrictions that for values of x that it cannot equal are -5 and 5. So x is equal to 1. We are set, and that's my answer. And you absolutely, totally check your work. You can plug in x, 3 plus 1 is 4, 4 over -4 is -1. Does this equal this? And check it that way. For this problem here, I do notice that I can have some values that x cannot equal 2 and x cannot equal -2. So those are my restrictions. So in trying to solve this, I am going to multiply everything by a common denominator, which is a combination of x plus 2 and x minus 2. So that when I take this value and I multiply by 2, the x plus 2's cancel, and I'm left with 2 times x minus 2. And then when I multiply this quantity here by the middle term, the bottom term, those both cancel, and I'm just left with plus x squared. When I multiply this term by this, the x minus 2's cancel, and I'm left with 1 times x plus 2, which is just x plus 2. Distributing this 2, I get 2x minus 4 plus x squared is equal to x plus 2. Again, it's quadratic, so that means that I am going to set it equal to 0. I'm going to move this x over to the left, and so I get x squared plus x. I'm going to move this 2 over to the other side, and that's minus 6 equals 0. I'm going to factor this out since it is set equal to 0, and I get x. To get -6, I'm going to have a 3 and a 2, but because it's the middle term is positive, that will be positive 3 and then a minus 2, so that when I split this up, I get x plus 3 is equal to 0, so x equals -3, x minus 2 equals 0, x equals 2. But in my restrictions, I already said that x cannot equal 2, because if x was 2, I would have 2 minus 2 on my denominator, which would make that 0, which would make it undefined. All right, so therefore my solution for this problem is going to be -3, but I do need to show that 2 is an answer. So the correct way to actually write this is to put the 2 behind the solution set, and so that shows that you have an answer. You do need to also write the restrictions. I may ask you for the domain for this, where you would graph this. You totally can graph this. This is something you could do, and this would give you some domain issues. For example, x cannot equal 2, so there would be no value here, and there would be no value here. So right off the bat, that whatever this graph looks like, and yes, you can just graph it on your calculator, but whatever this looks like, that it's going to go from -infinity to here, which is -2. So if I asked you for your domain for this problem, you would just say -infinity to -2, union with, and then it'd go from -2 all the way to +2, and then also it would go from +2 to infinity, and definitely graph that to verify that goes all the way through, but that's what I would do. For this problem here, you are looking at squaring both sides. To make this slightly easier, a lot of times people will move one of the terms over to the other side. And in this may help with like maybe 1 or 2 steps, but not too many. So if you choose to leave it on one side, that is completely fine. I'm going to move this over to the right to try to make this as less steps as we can. And So here we go. We're going to try to solve for x and get rid of the root so that we can get x out of the root to isolate that to solve. I'm going to square both sides. So when I square the side on the left, I'm going to get 2x plus 5. When I square the right side, I'm going to use the shortcut, which we square the first term, which is 25. We square the last term. Now remember, when you square a negative, it becomes positive, so that's plus. And that would be 2 times 2, which is 4, times this value, which is x plus 6, because the root will go away multiplied by itself. It's x squared, square root of x squared, okay? Now, in the middle, you're going to multiply these two terms together. Now, remember, numbers get multiplied with numbers. So that's negative 10 root x plus 6. And then when you double that, that becomes negative 20 root x plus 6. So let's just simplify some stuff here. So rewriting this, we get 2x plus 5 equals 25 minus 20. And please do not subtract those. That 20, it's like multiplied by this, it's attached. The only way you can undo a multiplication like this is to divide. And then we have plus 4x plus 24. So I'm going to move everything over to the left that is not attached to this root. So 25 is moving over, 4x is moving over, and 24 is moving over 24. And so what I have on the left, it looks like, oh boy, I think I get negative 2x, and then let's see here, I have negative 25 plus 5 is negative 20, and then negative 20 minus 24 is going to be negative 44, and then on the right, I get negative 20 times the square root of x plus 6. Now, this isn't going to help that much, but it is going to help a little bit if I divide every term by negative 2. And so what that is going to do is just make it a little bit easier. So that's going to be x, these 2's cancel, plus, 22 equals, and the 20 and the 2 will cancel because not the root, numbers can't cancel with roots. That'll be 10 times the square root of x plus 6. And you're okay to leave that 10 there because we're going to square both sides again to get rid of this root. Occasionally, you have to square the problems twice in order to get rid of the square. So now what we have is, let's see, x squared, middle term, 22, double that, 44x, and then plus, what's 22 times 22? 484, is that right? I hope so. And then this will be 10 times 10, which is 100, times x plus 6. So this here becomes 100x plus 600. And then I need to move all that over to the other side. So I get x squared plus 44x plus 484 minus 100x minus 600 is going to equal 0. So this is now going to become x squared, and then 44x minus 100, 56, and then, so those are gone. And then 484 minus 600 is negative 116. And now I'm going to try to factor these, and yes, voila, I used my formula on my calculator that I have for the quadratic formula because that gave me the two values that I needed to know in order to factor. So that was like super quick. And so what I did was I said, well, this is now, because I knew that my two solutions were 58 and 2. So then I put this in here because that's a negative. X plus 2. Is that right? Negative 58, positive 2. Okay, so we split this up. We go x is equal to negative 2, and we go x equals 58. And that's such a satisfying problem, honestly. But yes, you have to take the extra time and check your answers. And when you do check your answers and you plug them back into the equation, you are going to get that 58 is not a solution. So that means that x is going to equal negative 2 and 58 is an extraneous solution because when you plug that back into the equation up top, it's not going to work. The left side of the equation is not going to equal to the right side. So therefore, it's not a solution, but it's an answer. Answers are those answers that aren't solutions. We call those extraneous solutions. Oh my goodness. Now this problem, I can't believe I gave this to you. I'm just kidding. What we have is the square root of x squared plus 3x plus 6, and this equals 1 plus, yes, I'm moving this over, just to save a few steps. 1 plus that, which is x squared plus 3x minus, 3x minus 1. And I am going to square both sides. And when I square both sides, on the left, I get x squared plus 3x plus 6. On the right side, I get 1. And then the last term, this is just plus, and there's no numbers here. That's just 1, right? So that's just going to be positive x squared plus 3x minus 1. Now, when I multiply these two terms together using the shortcut, right, 1 times 1, the ones are the only thing that I'm multiplying. And then, so I multiply those together, and then I double it. And so that's going to be a positive 2 times that root, which is x squared plus 3x minus 1. So I would, right now, try to cancel out any terms on the left and right side that are the same, because when you subtract, they are going to go away. So the 3x's are canceled, the x squareds are canceled, and if you notice also, I believe this is the 1 minus 1 also cancels, doesn't it? 1 here, and then minus 1, gone. So what I have left is 6 equals 2 root x squared plus 3x minus 1. And again, I'm going to square both sides, but before I do that, I notice that I have a 2 on both sides. And so now I have 3 equals this root, which is x squared plus 3x minus 1. So yes, now I'm going to square both sides again to get rid of that root. And I get 9 is equal to x squared plus 3x minus 1. The root's going to go away. Because remember, what we're doing is we're squaring a half power. And then that cancels, and you're just left with that number inside. This is a quadratic. So now we have 0 equals x squared plus 3x and then minus 1. Oh, excuse me. And then that's a minus 9. So minus 9. So that'll be minus 10. And so now we have to factor. And when I factor, I get x and x. For 10, I'm going to go positive 5 and a minus 2. And when I split those up, I get x minus 2. So you're going to go x minus 2 equals 0, x equals 2. You're going to go x plus 5 equals 0, x equals negative 5. And for this problem here, I believe that the 2, when I plug that back in, does not work. So therefore, my solution is going to be negative 5. And then 2 is kicked out of those little solution sets. And 2 is an extraneous solution. And that's what we call that. Okay? All right, next problem. For these two problems that you see on the review quiz, this is sort of like, here's my answer, and I need you to tell me what the question was. And so this is really just this is just very easy in that you say, well, first, there's just like it's like a, formula. So first thing you do is factor. So we're going to factor x and x. We got a minus 2, and we got a positive 1. So once we've factored, then what we've got to try to do is, you see how you have 2 values down here? So what that means is that's a system of 2 equations, right? You're going to have 2 unknowns and 2 equations. That's what that means. So we're going to have A, first unknown, over this, which is going to be x minus 2. And then I'm going to go plus B, which is over my x plus 1. Because what's happened is that I've added 2 equations with those denominators. I don't know what the numerators were, but those would be my denominators. And so in order to find a like denominator, this needs what that has. And it's like, isn't that true with everything? Everybody wants what everybody else has, right? Anyway, this right here wants the x minus 2. So we're going to give it to them, okay? We're going to multiply that by x minus 2, but disguised as a 1. So it's not really getting what it wants. And this one, we're going to multiply by x plus 1 over x plus 1. And so now that my denominators are the same. Do you see that? That and over here, all of those denominators are the same. And in those problems that we just finished, you could actually multiply the entire equation, remember, by x minus 2 times x plus 1, and every one of those denominators are going to go away because they're all the same. So now what we have left is just what the numerators are, okay? And so those numerators are going to be 7x minus 5, and then on the right, you just have to distribute. You're going to get ax plus a times 1, which is a, and then this will be plus bx, and then minus 2b, okay? And right here is just a little bit tricky, right? So we're going to combine like terms. And so these are all the same, right? We've got 7x is equal to ax plus bx. And then the other values we have are negative 5 is equal to a minus 2b. Now, if you're looking at the left side here, what you should be seeing is that every one of these terms has an x. So it is very easy to eliminate that x because you're going to divide by every single thing. This being an equal sign, get rid of it. So we have 7. Now 7 is equal to, see how these x's are going to cancel? And so that's equal to a plus b. And so now we have an equation, 2 equations, 2 unknowns. You know multiple ways to solve this. You know elimination, substitution, Kramer's rule, you know, augmented, the Dementors, augmented matrices, and wait, what another one? What was that? Oh yeah, the calculator. Yeah, solved by that. If you remember how to do that, do use it. Because then you're going to check your work, of course. I'm just going to move this over to the other side, and I'm going to say that equals negative 5, and that equals 7, because I just, you know, prefer that over there. And so now I'm going to subtract my terms. And when I subtract my terms like this, a minus a gone. Negative 2b minus 1b is negative 3b, and then that equals negative 5 minus 7, which is negative 12, which gives me b equal to 4. So b is equal to 4, check. Plug it back in, find a. So pick one of these 2 equations. Don't use this thing. And so I'm just going to go a plus b is equal to 7. b is 4, so a plus 4 equals 7, subtract 4, so a equals 3. So the way you're going to write your answer for the test, of course, is going to be equals a, which is 3, so 3 over, now you got to be careful, because that, whatever you put up on the top is what a is over. So 3 over x minus 2 plus b, which is 4, over the x plus 1. And so this right here is the answer to my question, sort of like Jeopardy, right? 7x minus 5 over this thing. All right, and so you just box this up because that's actually your answer. For the next problem, this one is, I love this problem actually. You're probably not going to see a 3 by 3, but you're going to, I just thought this would be fun to just know that you knew how to do this. You do need to be able to factor this, and so I think what I tried was 3. Did I? 1, 2, negative 5, negative 6. Let's just review this. Let's see. 1, 3, 3 plus 2 is 5. What's that? 15, 10, 30. Oh, that didn't work. Whoops. Let's try a negative 3. Let's see. Okay. Let's see. Negative 3. So we get 1, negative 3, negative 1, 3, negative 2, 6, 0. Right. Of course. And so negative 3 worked. And so what that means is this, that x plus 3 times this stuff here, which is x squared, 1x squared. See this? Coefficients. 1x squared minus 1x minus 2, and that equals 0. So that's that value on the bottom. So I'm going to lose this. Goodbye. If you didn't get a chance to copy that down, just rewind, right? So this is what this equals, but remember, this actually can even be reduced again, right? X plus 3, and then factor that. So we've got x minus 2, and then we have x minus plus 1, right? Wait, yeah. Okay, so now that is actually my values that are all completely done. So I guess maybe, can I move this? Let's see. Let's move this. Do I need to? Nah, let's leave it. Okay. So this is going to equal, now notice I have three terms, one, two, well, not three terms, but I have three quantities on my denominator. So this is going to be a over, pick one, x plus 3. But don't forget what you used, okay? Because different people are going to put these in different order. So these need to match up with what you put over what, okay? So like somebody might have put the x plus 1 first, and that would be their b. So you just got to be careful. Plus b over x minus 2, and then this will be plus c over x plus 1. And so now what you're looking at is this. This is a little bit tricky now. God, that scared me. The common denominator is going to have three different values, right? Quantities. So this right here is missing this and that. So you would multiply this term by x minus 2 and x plus 1. This quantity is missing the x plus 3 and the x plus 1. And this quantity is missing the x plus 3 and the x minus 2. And of course, all of that is over itself, right? X minus 2 times x plus 1, x plus 3 over x plus 1, and then this will be an x plus 3 times an x minus 2. When you multiply by that common denominator, all of those denominators go away, and you're left with what is just on the numerator. And so realistically, this is a little bit tricky problem, but I do feel that there is value in knowing this because it's a little bit challenging, and I like that. So we've got a times x squared plus x minus 2x is going to be minus x, is that right? Minus x minus 2. And then the b will be times x squared plus 1 plus 3, which is plus 4x, and then plus 3. And then the c will be plus c times, I'm going to look at that. That's going to be x squared plus x, and then minus 6. And then what you're going to do now is distribute those a's out and set everything equal to each other. And when you do that, I'm just going to jump right to the bottom because you can see the answers on my page on the practice page. But what you end up getting when you set your x's together, like 4x squared, your ax squared, your bx squared, and your cx squared, is this. You're going to see a plus b plus c, that equals 4. See how you divide by x squared? And then the second term is going to be your negative a plus 4b plus c, and that's going to equal 15. And then you're going to see negative 2a plus 3b minus 6c equals negative 1. And what you're going to do at this point is, yes, you can absolutely do this by hand, or you can use your calculator because this is a 3 by 3. This here is your 3 by 3, and this is times your 3 by 1. This is a 3 by 1, and the 3's cancel, so you're going to end up with a 3 by 1, of course, and your values are going to be a equals negative 1, b equals 3, and c equals 2. Use a calculator, but the way you write your answer does look like this. That negative 1 goes above the a, where the a is. So that's negative 1 over x plus 3 plus b, which is 3 over x minus 2 plus 2 over x plus 1. And so this right here is the solution. Cool, right? I know, right? Okay. So then you're going to have these kinds of problems. The last kind of problems are just a bunch of variation, or maybe just one or two probably. But yes, you do need to know these, and they are going to be in the form of a word problem. So this just, I think for me, if you can get what you do with the given points, then you're going to be completely fine with whatever form they give you the question in, because you'll know what to do with it. So let's look at these. When they give you points, you need to chart it or table it, okay, for x and y. So let's do that. So we have 275, we have 10, 3, we have 50, and then 0.12. And so what you need to remember is this, is that it is expected for you, that's all they give you, right? For you to look at that and go, okay, what are they doing? How did they get from 2 to 10? Looks like they multiplied by 5. How did they get from 10 to 50? Looks like they multiplied by 5 again. Awesome. So this is definitely variation, because on the right, we're not multiplying by 5, but are we dividing by 5 squared? Is that right? Yeah. So 75 divided by 25 is 3, but for this to be a direct variation, you have to use that same number. So we're going to be multiplying by 1 over 5 squared. And then to get from here to here, check it on your calculator. 1 divided by 5 squared. So what this means for this problem is that, what type of problem is this? This is an inverse square variation, direct variation. Okay, and what that means is I can come up with a general equation. Now, a general equation does not fit this particular equation like specifically, but it's like a general inverse equation. So what that means is, for part B, is all I have to do is write it out like this. Y is equal to k being my constant. We don't know what that is. We'll have to figure that out. But divided by that value, x squared. So that's an inverse. Whenever you're looking at an inverse, you are dividing by x. Okay, you're dividing. Now, to find the actual particular equation, we have to use the points here into our equation. But the first step is to actually find k. You have to find k first. And so what we're going to do in order to find k is I'm just going to use this top point, 275. So I'm going to go 75 is equal to k over 2 squared. So k is equal to what? 75 times 4? Is that 300? Okay, and so that's my k. And so do a happy dance, you found k. And so then, though, you're not done, because you just found k. And the question says, find the particular equation for the values that you have. So now you're going to plug k in. Go back to your general equation and now make it specific. So we're going to go y equals 300 over x squared. And so now this right here is our super awesome particular equation, because it is rooted in our table. Check. The next question says, well, what if x equals 31.4? So for part D, we are going to plug in that value down here. So we're going to go y is equal to 300 over, what is it, 31.4? And then that's squared. So that value, use your calculator. I don't have it in front of me, but I have my answers in front. So that's going to be 30427. Done. Okay, 7. All right, so then that's done. And then the last problem for this is E. So they want you to plug in for E. They want you to do it, make sure you can do it in both ways. So now I'm going to plug in 1.95 for Y. So I'm going to go 1.95 is equal to 300 over x squared. I'm going to cross multiply, get 1.95 x squared equals 300, divide by 1.95, and I'm going to square root both sides. What do I get? 12.4. So x is equal to 12.4. So, I mean, this is just the rote. You have 3 points, find the equation, find the general equation, find the particular equation, and then plug in the values they want you to find. It doesn't matter if it comes into a word problem. Just find the points and then go from there. See what the patterns are. So for this problem, same thing. We're given a find the pattern. Okay, we've got x and y. We have 3, 5. We have 12. We have 320. We have 48, and then we have 20,480. So for me, this looks pretty basic. Times 4, right? So times 4 times 4. And so if I'm trying to find a direct variation, then I need to use 4. Okay, so I'm going to try to use 4. So what am I doing to get here? So, 5 times 4 is not 20. So I'm going to use my calculator. And I would just say, what's 320 divided by 5? And I get 64. So when I divided this by this, 320, divided by 5, I got 64. And now my question is, how can I relate that to this? Because if it's a direct variation, it has to be the same number, right? We're going to use 4 somehow. And 64 is actually, how many 4s? 4 times 4, 16 times 4 is 64. 3 4s. So this is times 4 to the third power. And then I would just double check, right, and make sure that I'm multiplying by 4 to the third power on both sides. So we call this a direct cube variation, because whatever value I'm multiplying on the left, I'm multiplying the same value, that's the direct part, but to the third power. So that's where it's coming into saying it's a cubic. So we call that a direct cube variation. Okay, so the next question is saying, what does that look like? What is a general equation? Well, the general equation is just going to be y equals, use your constant. We don't know what k is. We're going to find it. But y equals k, some number, times x to the third power. That's it. For part C, it says, now find the particular equation. Well, for the particular equation, they want it to represent the table. So what we need to do is pick a point. I'm just going to use 3, 5, because why not? And we have 5 equals k times 3 to the third power. So we get, what is that? 3 times 3 is 9 times 3 is 27. So we have k is equal to 5 over 27. Fine, that's so easy. But now that we have k and we are doing our happy dance, that's not the answer. They want the particular equation. So you take your k and you plug it back into your equation to find the particular equation. So we go y is equal to 5 over 27 x cubed, x cubed. Gotta be careful. I can't get that on a smaller setting. Anyway, what am I doing? Oh, x cubed. And so that's my particular equation. The last two parts, and this will be very similar to your quiz, because once you have yes, you will be asked for the general equation. Yes, you will be asked for the particular equation. And yes, you will be asked 2 other values. One's going to be x and one's going to be y. So when you find these, so for D, they're saying, hey, plug in x is 6.2. So just plug it into your equation, right? So you're going to go y is equal to 5 over 27 times 6.2 to the third power. Solve it. Use your calculator. Calculator is your friend. I think, what do I get? I did this already. I don't remember. I think I get 44.14. So 44.14. And yeah, I think on the other thing, I think what I did too was I made this into a decimal. You can totally do that. You don't have to, but you can. So last one is E. And because I'm not the best writer, you probably noticed that. I'm a little, I don't know, I just never did. Anyway, okay, y is 445. So 445 equals 5 over 27 times, what's x? Oh, that's what we're finding. Okay, so first thing you do is you've got to deal with this 5 over 27, so multiply by the reciprocal. So you're going to go 445 times 27 over 5, so whatever that makes. And I think what I get, I think I got 445 over that value. Okay. Now, and then after you're done with this, and hey, leave it like that if it makes you happy, divide by, or multiply to the 1/3 power, because that's how I'm going to get x isolated. So now we have x equals this super crazy thing, which is 13. 13.39. And so that's what x is. So whatever this was asking, the value of x at 445 is the value of x when y is 445 is 13.39. Done. So these are slightly different. Oh, I can't spell very well, but I guess this says not poser, but it says power. Sorry about that. Power. Okay, so given that y varies directly with 2.8 power of x, well, that is kind of crazy because that's saying x to the 2.8 power. Okay, find the value of the constant if the function contains this point. So they're not giving me a table. So, okay, but then they have to tell me what it's doing. And what they're doing is they said it varies directly. So what that looks like, right, when something is varying directly, it's just varying directly. So you are basically saying y is equal to that value k times x to the, what, they said 2.8 power? Okay, and so that's the general equation. So it's like a pattern, right? It's like something you follow. Step 1, find the general equation. Check. Step 2, find the particular equations, which means we have to find k, which means that we need to take our point and plug it in. So we're going to go 29 is equal to k, because we have to find k, times x. What's x? 45 to the 2.8 power. So all you have to do is go k equals 29 divided by 45 to the 2.8 power. And so what I get, k is equal to, what's k? Hold on, I'm thinking. K, boom. It's like 0.0006814. Okay, awesome. So 0.0006814, that's k. So again, happy dance, circle that, happy, 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 plug it back in. So we're going to get our equation, our particular equation is y equals 0.0006814 x to the 2.8 power. So this is my particular equation done. Now, next question, B, find y. Now, I do want to just stop for a second and remind you of something. They're not telling you to do this. You have to know to do that. So you have to know to find the general equation, number 1. Number 2, you have to know to find k. Number 3, you have to know to plug in k to find the particular equation. And the particular equation is the equation that directly addresses the points that they gave you. Okay, so there's no directions here that says do these 3 things. You have to know that. Okay, all right, so now that we have our equation, we're super happy because we can use this equation for any values that they give us, right? We're good to go. And so now I'm going to plug in x because they said x was this value. All I have to do is plug that in right here. So I would go y equals 0.0006814x. X is 13.6 to the 2.8 power. And then you just let your calculator have fun. And then I think for this part, for B, I got 1.017. So y equals 1.017. And for C, we get, it says find x. Now if y, so we plug in that value for y. So we go 53.8 equals 0.0006814x to the 2.8 power. We take 53.8, we divide by this number here, right? And then you have x to the 2.8 power equals whatever that is. I think it's 78,000, something like that. 78,955.1. And then in order to get rid of this 2.8 power, you have to go 1 to the 2.8 power. So this quantity gets to the 1 over 2.8 power. This is all calculator work, you guys. You have to, know your calculator. You're done. You get x equals 56.113, so 56.113. And that's x when y is 53.8. The last one of these, I have one more problem after this, but a surprise. Given that y varies indirectly, okay, they only gave us 1 point. And if they only give you 1 point, that's not enough to chart it, you guys. It's not enough. And so what you have to do is you have to take this point and they have to tell you what's happening. And within the question, if they only give you 1 point, they're going to tell you what is happening. And what is happening is it varies indirectly. But then they said, hey, we changed this power. Power is x to the 3/5 power. So your general, number 1, find the general equation. So y equals k, and it's directly, so it's going to be times x to the 3/5 power. Done. So now we have to find k. And so did it say indirectly? Oh, it did. Oh. Indirectly. This is directly. And let me fix that. Varies indirectly. Indirectly, it means divide. So here we go. I almost made a mistake. Almost. Okay, here we go. K over x to the 3/5 power. So now we found the general equation. That's your first step. Second step, find k, right? So in order to find k, we need to plug in the one and only point they gave us. So we go y is 7.8 equals k over x, which is 13.4 to the 3/5 power. Now 3/5 that's 0.6, right? So I've seen people do this, though. Just want to give you a heads up. You could do this. 7.8 equals k times 13.4 to the, that's 0.6, so to the negative 0.6 power, because they brought that up. You totally can do that. I don't care if you do it or not. That's your choice. But in order to find k, we need to, cross multiply or do whatever we have for that. And then use your calculator, find k. I get k equal to 37.01. So find k. Happy dance. Check. Yay, we got that. But that's not the equation. We need the particular equation, which then is going to be y equals k, which is this 37.01 all over x to the 3/5 power. So this is our equation of our particular equation. And now we can use that to find these values. So plug in x to that equation. We're going to get y is equal to 37.01. This is part B. Over x. X is 23.9. So 23.9 to the 3/5 power. Calculator. And then I get for that value B, what did I get? B, 5.5. And 5.51 is what I got. And then that's the answer I received. And then this right here, find when y equals that value, find C. So, find x. So y is 3.6. You're going to go 3.6 equals this stuff. And you're going to get 37.01 divided by x to the 3/5 power. And cross multiply, and I'm going to get, what do I get? It's a little bit tricky. Look at my answers. But I do get x, finally, after I cross multiply and divide, I get x equals 48.61. So find my worksheet. Look at the answers. I got all the steps there. But for the sake of time, you guys hate long videos. I'm sorry. And I'm going to go on. Last problem. The number of minutes. So, yeah, this is a wordy problem. Same concepts. Use your brain on this. Figure out what they're saying. The number of minutes it takes to cook bacon in a microwave oven. We all done this. I expect you guys to tell me if this is right or not. The number of minutes it takes to cook bacon in a microwave oven depends on how many slices you put in at once. So something depends on the other. A popular brand of oven specifies 1.75 minutes for 2 slices. You guys, that is a point. For every 2 slices, it's going to take 1.75 minutes. And then they said, well, 2.5 minutes is going to be 4 slices. So now I've got 4. So here's what I'm going to do. I'm going to make a table because they actually gave me more than 1 point. Okay, so I'm super happy about that. So we've got 2 slices, and that gives me, I'm going to make this x and y. Oh, no, I should use the letters they gave me. I think it was S and something else. Maybe minutes or seconds. Slices. Okay, so here we go. We've got our slices, 2 slices, and T is minutes for time. Okay, all right, here we go. 2 slices gave me 1.75 minutes, and 4 slices gave me 2.5 minutes. So, what is it? What does it say? Popular brand, okay. Well, that's all they give me. So now I have to come up with an equation. I'm looking at this, and it looks like I'm timesing by 2. But timesing by 2, it's not a direct variation. So why doesn't the number of minutes vary directly? Because I'm not multiplying the same number. If I multiply 1.75 times 2 is not 2.7, is not 2.5. So that means that that it's something else, and I don't know what it is, but I do know that what I have to do, because it is a direct variation. How do I know it's a direct variation? I know it's a direct variation because it says the number of minutes it takes depends on, that's your variation, how many slices there are. So this is going to be, assume that the number of minutes varies directly with some power of the number of slices. So we're going to do a direct variation with a power. So we're going to go y equals, let's go k and then times x to the nth power, because, and that, oh, and I'm using the wrong letters, sorry, t and s, I like these better. Anyway, what you're going to do now is you're going to pick one of your points. Let's do that right now. Let's plug this in. So we get one of our points is going to be 1.75 for y equals k times x2 to the nth power. So check this out. I've got a k, that's an unknown, and an n, that's an unknown. Two unknowns. I need two equations. Thankfully, happy dance, we have 2 points. So the other point is going to be this. 2.5 is equal to k times 4 to the nth power. Okay, two equations, two unknowns. Okay, so you have options now. Here are your options. We need to find k because we already have our general equation. Remember, and our second step is to find k. So what we're going to do, but I can't find k yet, because what's going to happen is, because I've got two equations, I actually have an extra step. And what I'm going to do, see how I flipped that? What I'm going to do is I'm going to divide. I don't know if you guys remember this. We did this with exponential equations. I'm going to divide the top by the bottom. And what I'm going to do with this is, see these k's, they're gone. Divide, sorry, they divide out. And I end up getting, when I divide these out, I get, oh, remember when you take the base, you have to have the common base and before you can subtract your exponents. So this 4, I'm actually going to change that 4 to 2 squared. So 2 to the 2n divided by 2 to the n. Keep the base, subtract your exponents. So 2n minus 1n is 1n, right? So we've got 2 to the nth power is equal to this. I don't know what that number is. What is that number? Well, it doesn't matter. It's going to be 2.5 over 1.75. Okay. Now, a couple of things you might want to recognize. Number one, my variable is in the power position. And what that means is, if my variable is in my power position, well, that has to come out. And so that I'm going to need to log both sides. So I'm going to rewrite this because I like this better on the left. You know, it's just weird. 2 to the nth power is equal to 2.5 over 1.75. I mean, yes, you can get a better number for that. But anyway, bring this n out front. So we have n log of 2 equals log of this value, still, yeah, still there, 1.75. And then I need more space. And then what I'm going to do now is I'm going to divide by log 2. And so I'm going to get n is equal to this log of 2.5 divided by 1.75 divided by log base 10 of 2. And we talked about how to plug these into your calculator. Those who have the TI Inspire, this would be log base 2 of this, you know, with the change of base form. I end up getting, for this problem, n equals 0.5145. So there's my n. Okay. So what that does for me now is that gives me n. And so I can plug this in here, because in order to have an actual general equation, I can only have one unknown. So even though I said that was my general equation, it was like general equation. So here we go. Y is equal to k x to the nth power, which is 0.5145. So now this right here, that is the value we need. That's our general equation. Okay, but now we have to find the particular equation, and to find the particular equation, I need k. So pick a number, either one, to find k. So we're going to go 1.75 equals k times x. What's x? X is 2 to the 0.15, 0.5, I know, 0.5, I'll get it, 0.5145. So divide both sides by that value. I get k, I just did this, k is equal to, I think, 1.225. 1.225. So there's k. Happy, happy, happy. Take k, whatever that is, and plug it in back into this equation here to get your particular equation. And so finally, we get the particular equation, and that's going to be y equals k, which is 1.225 x to the 0.5145 power. And what that did just right now is that gave us the equation that we can use for any problem to figure out what they're asking. And you better believe they're going to say, hey, what if x equals this? What if y equals this? What if I have, the questions for this might be, what if I have 6 slices of bacon? Well, I would plug in for x. See, these are slices, right? For x, I would plug in 6, and then that would be x. What if they said, hey, but my microwave is going to turn off after so many minutes? Well, then y is going to be that value. So you have all of this information. You can plug in anything that you want. And this actually is a question out of your textbook. So it's the last problem. So yes, it's a little bit challenging for sure, but probably be less challenging on the test, but who knows? You never know. But now you know how to do this, and you can, anything less than this will be so much easier for you, right? So I wish you good luck. And by the way, this is Shanghai 10 Rings, new Marvel. Good luck on your quiz. Thanks so much for watching. And I always really appreciate it when you guys say something nice, of course. Have a great night.